So this is to explain a little bit more about R squared, which is the coefficient of determination. The context for this problem, if we are trying to predict a backpack weight, so how heavy is the pack weight for a new hiker based on their body weight. But the idea is, what if we didn't know each of their weights? So what would be the best pack weight guesstimate, really? So we can use the average backpack weight, which is the darker blue line that's around like 28.5. Not a great prediction. And so remembering what R squared is, we do have one measure of the residuals, which is the standard deviation of the residuals S, but then R squared is another quantity that tells us how well the line will predict the values of the response, in this case, the pack weight. And so this here would be the interpretation, so the fraction, or we could say percent of variation in those response values that's either accounted for by the least squares regression line or explained by. And so this is a formula that we don't have to do a whole lot with, but maybe you saw in pre-calc. So it's the idea of the residuals and how far the points deviate from the least squares regression line, which is what the residuals would be, versus the total if we just, again, didn't have any idea, and so our best guesstimate was to use the average instead for everyone, which is the SST. And so this visual should help to better explain. Suppose we have these couple of points and we were interested in this one particular value of X and its actual value of Y. You can see how much error we have with respect to the mean model if, again, that was our best guesstimate. So if we fit a least squares line to it instead, we've eliminated that much of the error from what the mean was producing to what the residual or regression line, is predicting. And so it's still not perfect, but it's a lot better. And so the proportion of error eliminated is one way to think through it. And so looking again at the SST, the error with respect to the mean model, and then how much did we get rid of for the regression model is what R squared is, the proportion or fraction of variability accounted for by that given model. And so another visual with the backpack and the body weight, that if we used the mean model, again, like 28.5-ish, for everyone, not so great. You can see the sum of the squares there versus the least squares regression line. And so we've reduced the sum of those squares instead. And these, again, are residuals because it's from the actual point to what's predicted by the least squares regression line. So we can either think of how much is unaccounted for, or, again, that subtraction from the earlier slide that shows how much is in fact accounted